natural log as integral. For x greater than 0, define the natural logarithm function by ln of x equal to the integral from 1 to x, 1 over t dt. So recall dx of ln of x was 1 over x. Right? So then integrate 1 over x will get you back to ln of x, basically. So the theorem, for x greater than 0, the derivative of the natural logarithm is given by ddx of ln of x equal 1 over x. Then we have the corollary. The function ln of x is differentiable, therefore this is a continuous function. Calculate the following derivative. We want to take the first derivative of the function of ln of 2x squared plus x. So here we need to take the derivative with respect to x and also apply the chain rule. So this becomes 1 over 2x squared plus x times the derivative of 2x squared plus x would make 4x plus 1. So then we have 4x plus 1 divided by 2x squared plus x. In the next case, derivative of ln of x to the third square. So here you are looking at dx of ln of x to the third times ln of x to the third. Okay. So we have to use the product rule here. So derivative of ln of x to the third, the first one, is 1 over x to the third. Derivative of x to the third is 3x squared times ln of x to the third. That's the derivative of the first part. The second part will be ln of x to the third times 1 over x to the third times 3x squared. Simplify and combine like term. We get 3 over x ln of x to the third plus 3 over x ln of x to the third. This equal to 6 over x ln of x to the third. Let's use substitution to calculate this integral. Well, we'll let u become x squared plus 4. Then du is equal to 2x dx. This means x dx is equal to 1/2 du. I can rewrite this integral as the integral of 1/2, and I put the number up front, of 1 over u du. This is 1/2 ln of u plus c, and u is equal to x squared plus 4 plus c, where c is a constant. Let's take a look at the property of natural logarithm. For a, b greater than 0 and r is the rational number, natural log of 1 equal to 0, ln of a over b is equal to ln of a minus ln of b. Ln of a can be equal ln of a plus ln of b. Ln of a to the r, we can bring the exponent out. This is equal to r times ln of a. So this property is the same for the property of logarithm, right? The property for natural logarithm and the property for logarithmic function are the same. Use the property of logarithm to simplify the following expression into a single logarithm. So ln of 8, I can rewrite this as ln of 2 to the third. minus ln of 2 minus ln of 2 to the negative 2. Let's put the first group together. Ln of 2 to the third minus ln of 2, that is equal to ln of 2 to the third divided by 2 minus ln of 2 to the negative 2. This means I have ln of 2 to the second minus ln of 2 to the negative 2. This is the same as saying ln of 2 to the second divided by 2 to the negative 2. That is ln of 2 to the second times 2 to the second. Ln of 4 times 4, that's 16, so that is 2 to the fourth. Let's define in the number e. The number e is defined to be the real number such that ln of e equal 1. So for any real number x, define y equal e to the x be the number for which ln of y equal e to the x, and that's simplified to x. And we have some property of exponential function. E to the p times e to the q is equal to e to the p plus q. E to the p divided by e to the q equal e to the p minus q. E to the p to the r. We multiply the exponent together. Let's evaluate the following. The derivative of e to the x squared divided by e to the 5x. Well, first we need to simplify this expression. This is d dx of e to the x squared minus 5x. Okay. Recall that d dx of e to the x is equal to x. Equal e to the x. The derivative don't change. Okay. So now here we have to take the derivative, and we also have to do the chain rule. So derivative of e to the x squared minus 5x is equal e to the x squared minus 5x multiplied with 2x minus 5. And let's simplify this again. D dx of e to the 6x. So derivative, we have e to the 6x times 6 equals 6e to the 6x. Let's evaluate the integral. Okay. So here you get the integral of 2x times e to the negative x squared dx. I will take derivative here with using the substitution rule. I go ahead and let u equal to negative x squared dx. So then du equal negative 2x dx. So negative du is equal to 2x dx. I can rewrite my integral as negative e to the u times du. This is negative e to the u, and this is equal to negative e to the negative x squared plus c, that is a constant. Okay. In the next problem, we go ahead and let u equal e to the 3x. Let u equal 3x. So we let u equal 3x. So du equal 3 dx. Note that you have a 4 dx in the integral. This meant that one third du is equal to dx. So 4 dx have to equal to 4/3 du. I can rewrite my integral as 4/3 times 1 over e to the u du. So this is the same as saying that I have 4/3 times the integral of e to the negative u du. Well, I know how to integrate when I have e to the u, but I don't know how to integrate when I have e to the negative u. So let's go ahead and do one more substitution. Let w equal negative u, then dw equal negative du. So negative dw equal du. I can rewrite my equation as negative 4/3 the integral e to the w of dw. So this equal to negative 4/3 e to the w. That is the same as saying negative 4/3 e to the negative u. And negative u, that is negative 3x. So negative 4/3 e to the negative 3x plus a constant. For any a that greater than 0, and for any real number x, we define y equal a to the x as follows. Y equal a to the x equal e to the x times ln of a. Derivative and integral involving general exponential function. Let a is greater than 0, then the derivative of a to the x equal a to the x times ln of a. And the integral of a to the x equal 1 over ln of a times a to the x plus c. For the logarithmic function, the derivative of log base a of x equal 1 divided by x times ln of a. So let's go ahead and do the following. We want to take the derivative of log base 3, the square root of x squared plus 1. So the derivative of the log, this is equal to 1 over square root of x squared plus 1 times ln of the base, that is 3. And then we have to do the chain rule. So 1/2 x squared plus 1 to the negative 1/2 times x squared times 2x times 2x. So this whole thing simplified to x divided by ln of 3 times x squared plus 1. In the next integral, we will let u equal x to the third, then du equal 3x squared dx. So 1/3 du is equal to x squared dx. I can rewrite my integral as 1/3 times 2 to the u du, and this equal to 1/3 times ln of 2 times 2 to the u, where u equal to x to the third. So I will clean this up. 1/3 ln of 2 times 2 to the exponent 3 plus c, that is a constant,